4.4a, I'm just going to call the first video A, even if we have only one video, just because I don't know what we're going to end up with. All right, in 3.4, we were doing the graphing of inequalities. So let me get a handy dandy graph out here. There we go. And put that over here. And we would have graphs such as x plus 4, x plus y is less than 4, and you were supposed to graph that. All right, so if you want, you can make your xy here and make a table, or you can change this to slope-intercept form, which is, remember, is y equals mx plus b. So if we moved everything, we left the y on the left and made a less than sign, moved the x over by subtracting it from both sides, we end up in this format to where x was moved over here, y is left alone, and the 4 is left alone. And that puts us in y, x, and a number 4. So this is actually minus 1. And the minus 1 can be written as a fraction. Remember, the slope is m, and it can be written as a fraction, negative 1 over 1. And if you remember with slope, it's y over x. So that being the case, our y is negative 1 and is over 1. Now we can also take this 4, first of all, and put it as our y-intercept, and then we go this distance away from that point. So we go over 1, down 1, over 1, down 1, etc. until we get a line. Notice my line is dotted because it's a less than sign. If this had an equal sign under it, less than or equal to, it would be a solid line because it could be equal to the line. But since it's less than, it stays there. So let's go ahead and shade this in red. It's less than, so it's going to be everything below. And then let's look at another equation. And let's look at negative x plus y is less than or equal to 3. Let's do this the same way. Let's get rid of the y, or the x. Let's move it to the other side. And because it's subtracted here, I add it to both sides. And I always put the x first, and then there's a 1 in front of it, so it's 1 over 1. And my y-intercept, where it crosses the y-axis, is at 3. Do this in blue, is at 3. And then I go up 1 over 1. And because of the less than or equal to sign, I get a solid line. And it says that my y is less than that. So I'm going to shade everything below the line. So we learned to do that. Okay, the difference is with this lesson and the other lesson is, notice I have two equations that I was doing. I've got this equation here and this equation here. So I graphed them both on the same graph. And what I'm interested in is what is the solution to this system of linear equations. So linear equations mean that we get a straight line here and we get a straight line here. The graph of the inequality means that we shade everything below less than y, or greater, y is less than, so everything less than. And over here it also says y is less than, so we shaded everything less than or equal to. That's why we have a solid line here. So the system of equations says we need to know the numbers that make both this inequality and this inequality true. So we shaded this red, we shaded this blue. Wherever the red and blue intersect, where they have commonality here. That is the answer. Those are all of the points that will make both this and this true. So therefore, all of this can go away because it doesn't make both equations true. And you can test it by picking a point. Let's just pick 0, 0. So if I took our original equation, x plus y is less than 4, is 0 plus 0 less than 4? Yes. Then we take this one. Negative x plus y is less than or equal to 3. So is 0 plus 0 less than or equal to 3? Yes, it is. So therefore, if this point makes both inequalities true, then all of these points will make the inequalities true. Now, if I picked a point up in here and plugged it in, these would not be true statements. So that's one easy way to check to find out if you got the right section shaded, is pick a point there and plug it into both of the inequalities. And if it works for both of them, then you're on the right track. Okay, so this is example 1 on the bottom of page 362, and I'm going to make sure you get lots of practice using the slope-intercept form, and these are both already in that form. So this says that this inequality crosses y at 3, and the slope is 1/2, or y over x, which means we go over 2, up 1. And then we draw a line, and it's going to be a dotted line because there's no less than or equal to sign. And because of this less than sign, I'm going to shade less than the line. So let's do this in red. I'm lucky I have a highlighter. Okay, now we're going to do the same thing here. Except this time it crosses the y-axis at -2. And it's a greater than or equal to sign. So let's get the line drawn first. So y is a positive 2, or I'm sorry, y is a 1, and x is a positive 2. So that's going to be right there. And it's going to be a solid line. And it says y is greater than. So that means I'm going to shade everything above. So what I'm interested in then is where we have common numbers. So wherever the shaded intersects, yep, that one isn't erasing very good. There we go. Wherever that intersects is the answer. That's the graph that will make both of these equations true. All right, so that takes us to example number 2. Okay, here we go. Let's change this to y is less than -1x plus 4, which is 1 over 1. It crosses at 4, and we go down 1 over 1. So that gives us a dotted line that does this. Dotted because there's no less than or greater than or equal to sign. It's just a less than sign. And because it says that it's less than, it means we're going to shade. Let me get a big marker out here. It's going to shade all of this. Okay. Now we're going to look at these next two. This one here. X is greater than or equal to 0. X is greater than, let's do this in red, means that our x value is going to be greater than 0. So it's going to be all of this over here. Anytime x is greater than 0, that number is going to work. This next one says y is greater than 0. So let's do this in green. So it'll be everywhere that y is greater than 0. Wrong marker. Okay, so what we've got here is 3 different graphs, and all we care about is where they intersect. So where they intersect, I'll do this a little bit bigger, is right here. And remember, this one line here is dotted, so this will be the dotted part. Okay, because this was greater than or equal to, so it included the x-axis right here. And this is y is greater than or equal to 0, so it's going to include the y-axis here. So that is what you're going to get for your answer there. Okay, these are the ones that are a little bit easier to graph because we don't have a whole lot to graph. We have x is less than or equal to 4. So all we care about is a solid line through 4. And it's solid because of the less than or equal to. And then we've got y is greater than or equal to -3. Okay, so that's easy enough. So as far as our highlighting goes, x is less than or equal to 4. We're going to graph all of this. And then in yellow, y is greater than or equal to -3. We're going to graph all of this. And then all I care about is this area right here where the colors intersected. All right, jump to 4, example 4. Okay, so for number 4, we've got 3 different graphs. So let's go ahead and change that to -2y is less than or equal to -x plus 4. We're going to divide both sides by -2, and that will switch our sign. To that, because this is going to be x over -2 or -x over -2, which makes it a positive. And this will be -4 over 2 or just 2. In fact, we're going to change this x that I have here. Let's erase that with my little micro eraser. And we end up with 1/2 x. So that gives us a lot more to work with as far as getting it in slope-intercept form. Now I can graph where it crosses the x or the y-axis. If I get a pencil here, which is right there at 2, and this gives me a slope of 1/2, which means I go over 2 up 1. And because of this greater than or equal to sign, I have a solid line. Then I have to look at the next equation, this one right here. And let's move this out of the way here so I can get it in slope-intercept form. Notice I did not change the sign here because I did not divide or multiply by a negative. I just subtracted x from both sides. So that gives me y is less than or equal to -1 over 1 x plus 4. Need to change my color to blue. I cross the x or the y axis at 4, and I'm at 1, 1, so I'm down 1 over 1. And because of the less than or equal to sign, I get, again, a solid line. All right, so let's go ahead and shade these before we go on. The one shading for this one I did right here says that y is greater than. So that means I'm going to shade above the line. Everything above the line. Okay, and this one over here says it's less than. Y is less than, so I'm going to shade below the line over here. All right, and now the last equation says that x, and I'm in example 4 here, is greater than or equal to -1. So that means I'm going to get a solid line through -1. and it says my x is greater than, so I'm going to shade everything to the right of it, which tells me that let me get black here, my intersection is going to be where all three colors meet, this area here. That will be the answer there. So any of the numbers in that black triangle that I put in for this equation, or this equation, they're all going to work. They're all going to make that a true statement. So that's example 4. In example 5, I'm going to go ahead and skip. I'm going to let you look through that. It's basically the same thing we just did. It's only using story problems to come up with an inequality and then graph it. But in the homework, number 23 is the only one I gave you that has to do with a story problem, and it's really pretty simple. So anyway, I'm going to skip doing that so you can get started. This lesson only has a few problems in it because they do take a little bit of time to do, and once you learn how to do them, you really don't need to do tons and tons of them. So that's it for 4.4.